Hello, and welcome to Introduction to Problem Solving. My name is Katie, and I'll be guiding you through the next 11 lessons on problem solving. As you learned in the first introductory module, there are two definitions that come to mind when we think about problem solving. First is the day-to-day life or work definition. That is, a difficulty or issue that needs to be overcome. This could be any kind of difficulty, from finding one's keys to unclogging a sink, to cooking a meal for an entire family. The second definition that comes to mind is the math or science definition that we tend to encounter in school. That is, a question that needs to be answered or resolved, sometimes to gain points on a test or sometimes to gain points for homework. When we look at these two definitions, we see that there are parallels between the two. In each case, everyday and mathematics, there's an explicit component, a thing that exists, and an implicit component, what we would do with that thing. So for the everyday definition, the explicit component is the difficulty or issue, and the implicit component is the understanding that we need to overcome that difficulty or issue. In the mathematics definition, the explicit component is the question, and the implicit component is the need to answer or resolve that question. The trick of problem solving is converting the difficulties and issues of everyday life into questions that we can then answer to overcome the problem. So what is mathematical problem solving? We can think of this in two ways. First, we can think of the skills and techniques that we use in mathematical problem solving. These include the subjects you learned in school, such as arithmetic, algebra, geometry, statistics, and calculus, and the techniques you learned in those classes, like graphing and data visualization, and logical reasoning and thinking. You can also think of mathematical problem solving in terms of the kind of thinking or the nature of the work that you need to do. Mathematical problem solving is fact-based, comprehensive, and systematic. From your previous mathematical experiences, you're probably very strong with the doing math component of things. This course is about learning to apply that math to thinking like a mathematician. So doing math after thinking like a mathematician. You'll combine both of these skills to become a good problem solver. As you work to become a strong problem solver, we'll come back to 4 key skills time and again. These 4 key skills will be applied in sequence in every problem that you work to solve. The first skill is understanding. That is, identifying opportunities to problem solve using mathematics in a variety of different contexts. The second skill is strategizing, or selecting an appropriate technique from mathematics to address problems. The third key skill is solving the problem, or applying the appropriate technique and leveraging appropriate technology tools to come to a solution. And finally, and perhaps most importantly, is looking back, which is interpreting, applying, and communicating the information that you've learned in your problem-solving process. Among these key skills, we know how to do some very well, and we know less about how to do others. Looking at the arrow to the right, you'll see dots. The color of these dots indicates how well you know how to do each of these steps coming into this course already. Darker dots indicate that you're probably less proficient with this skill, and lighter dots indicate that you already know most of what is needed to succeed. In terms of understanding, you know some of how to do this. You're good at processing situations and understanding them, but you're not necessarily totally proficient at characterizing the situation and thinking of it from a mathematical or logical perspective. For strategizing, these are the core skills that you'll learn in this course. You probably already know a number of strategies for attacking problems, but in this course we'll define those strategies and help you to learn to identify when to use them and practice using them when solving problems. In terms of solving, you already probably know almost all of the math that we'll review in this course. The main purpose is to think about how we can use this math to implement the strategies that we'll learn. Finally, with looking back, you're probably good at doing some part of this. You know how to check your mathematical work, and you often are asked questions based on the solutions that you've obtained in your math courses. However, we'll also talk about how to extend this skill further by communicating the quantitative information that you've learned and interpreting it to ask more questions yourself. Of course, in any math course, you'll find yourself asking sometimes, why bother? You've probably heard of a number of reasons that you've needed to learn math in your previous courses. Teachers tend to explain that you'll need to use math for day-to-day life skills like cooking or making change or doing your taxes. And while these are important skills, the reality is that math isn't always necessary for cooking. You probably won't work in a store forever, and you could always hire someone to do your taxes. So why are you taking more math now? The reality is that there's much more to it. Mathematical problem solving is not just about computation. It's about understanding the world better, interpreting the information around you, and being more effective in your day-to-day life and in your job. You'll learn how you can use math to extend the information you read in periodicals and newspapers, or to draw deep conclusions that are not explicitly stated in research that you do for school, work, or in another context. You'll also learn that math can help you to problem solve, negotiate, and come to consensus in both your personal and your work or academic life. Math helps you to reduce complicated information into its simplest form, which allows people to look at it objectively. Finally, you'll learn that mathematical problem-solving skills will help you to plan, organize your thoughts, and reason logically in a variety of contexts that don't even require computation. I'm excited to walk you through this problem-solving course in the next 11 lessons.